I'm no longer just.
No, I count, actually I count 8.
6,
8. Yeah. I only have 8. So we're missing 2.
Okay, maybe I miscounted. Maybe they're all supposed to be 9.
Well, let's look at the agenda.
Yeah, I have the agenda here. 1, 2, 3, 4, 5, 6, 7, 8, 9.
9.
So we're
good.
Multitasking.
Okay. You want me to keep
I'm
time?
multitasker. Sure. I'll watch the Jabber and EDHOC. Right, but so she's projecting and keeping time. I'm watching Jabber and EDHOC. Where
You're taking notes.
so yes, that's a good question. Jim Shaw just asked who's taking notes. Now
Were you volunteering?
take that as him volunteering, but I'm not going to. I'm going to ask for somebody to watch Jabber and channel people who might say something there, and someone else to take notes, which means keeping track of basically what was discussed and what actions or decisions came from it. And we don't need a word for word thing. Do we have volunteers for those 2 tasks?
Please. We cannot start until we have the volunteers.
And while we're waiting for lots of you to volunteer, I'll say I'm Kapeng Lee and this is Hannes Schofenig. And you may not recognize us. We have very, very good Halloween costumes on. Now, actually, Kapeng and Hannes could not be here, and so I'm Barry Lieba, and this is Nancy Cam Wingett, and we are the substitute chairs for today. Don't abuse us, not like you do with substitute teachers. No erasers thrown, whatever. Okay, I babbled for a bit and no one volunteered. So let's try again. Volunteer, please, for channeling people in Jabber. It's really easy to channel people in Jabber. It's not a challenge. Okay, Karsten is going to do that. Slightly more challenging, but not terribly so, is keeping notes so that we can make minutes later, or so that the real chairs can make minutes later, probably. Would someone please volunteer to do that? We'll buy you cookies.
We have cookies.
Thank you, Brian. Brian Rosen generously volunteers to take notes, and he gets a plate of cookies. All right, time to start. So,
did you pass the blue sheets?
The blue sheets are going around. Please be sure to sign the blue sheets. And Nancy will put the chair slides up at some point.
Let me turn my Wi-Fi off so that I don't get pinged. Wouldn't that be good?
That makes sense. So excuse us for a moment for some chair twiddling and we'll get back to you.
Okay.
Alrighty. So let's get the agenda up. And so here's the agenda. At least I think that's what's on the screen.
Actually,
I can't see it.
Note well.
Oh, okay. Here's the note well. So note the note well. And basically it means that if you know about intellectual property, you probably need to disclose it. There are some ifs there, but look at those documents if you have questions. Next slide is the agenda.
Requests.
Oh, yes, we did that. Move on.
Did we pass the blue sheets?
Yes, they're around.
Okay, now milestone check.
Milestone check. Okay, here,
is-
why don't you drive the microphone because I can't see the slides.
Yeah, you're assuming that I can see as well.
Well, you can see them on your screen.
No, I can't. See,
Oh,
it's busted, man.
oh. Maybe you should mirror your screen so you have the same on both.
It was mirrored, but let me try again. Show mirroring options. Oops, arrangement.
Arrangement.
Mirror
Mirror
displays.
displays. It is on. Okay, that's odd. Well, go ahead and go back in. Let's see what,
Okay, now we
Yeah.
can see it.
all right.
Okay. So basically, the milestone check is the submission for the authentication and authorization solution. I guess in September, has gone through to the IASG for publication. Similarly, in May, there was a submission of the architecture for the authorization in constrained environments. And then I guess this is in reverse order. The other submissions have already been completed. I'm presuming that these two are remaining since they're not done quite yet. All right, so with that,
Did anyone not sign the blue sheets? Excellent.
oh, let me send it.
Yeah.
Okay. So we've got a very full agenda. I'm not going to read it out to you. But with that, should we just begin? See, I don't know why it's not keeping up.
Very odd. Okay.
This is very odd. Okay, so the first one up is.
Yeah, but
So yeah, before Karsten starts his actual presentation, he has something else to say. Right quick here.
we just had a core working group hallway meeting, and one of the many documents we looked at is a draft for doing EST, Enrollment over Secure Transport, over COAP. And actually there are two drafts, and there seems to be some interest in this. And of course, since there's COAP in the name, the core working group is looking at this with interest, but we are probably not the right working group to actually do the work. So this is just a heads up that there probably will be a discussion whether ACE is the right working group to get this work done. Okay, so the actors draft, next slide. That is an informational draft, and as you know, informational drafts are always a little bit on the back burner, and that has happened here as well. We have a number of good reviews. Most of them have been integrated, but then Robin Wilton wrote a pretty spectacular review, and it has taken us a while to integrate those, and we actually only have managed to do the first half so far. If you want to have a peek, it's in the working group subversion document, and doing his second half. We planned to have this done before this meeting, but it turned out this requires a bit more surgery. Göran has a plan how to do that, and I will do that when I'm back. And so I would like to shape your expectations. Look under the Christmas tree. There will be something there with respect to the actors draft. Any questions about that?
All right, next is Mike Jones. CBOR Web Token.
Thank you. I'm Mike Jones from Microsoft. Next. So the CBOR Web Token draft hasn't had changes since Berlin. No comments have come in. We are tracking the issues publicly. There's only 2 issues, both of which pertain to adding and validating example values in the specification. Next. So we're aware of Ludwig Seitz' CBOR Web Token code, and the editors plan to use that to generate some actual example values to put in the specification. The main reason I even wanted to stand here was to solicit volunteers once within a short period of time we have those examples for an independent party or two to validate them using code that's different than the code that we're going to use to generate them. So how many of you in the room have or are using COSI implementations? Francesca and Jim and Kirsten. So I believe Ludwig's code is based on Jim's code. It's the C#. It's the C# code. Okay, so would somebody be interested, in order to help move this along, to work with the editors? Karsten is nodding, thank you. Because we do want the examples to both be useful and correct. That's all I have. Thank you, Karsten.
Wow, you guys are doing awesome.
All right, we're zipping right through here. Next is, yep.
So over Java, Ludwig reminds us that it is really not a very large task to do a CWT if you have a COSI implementation. And actually he's using the Java code by Jim and not the C# code.
I don't think I have it. Base data gram transport, lightly authenticated time, 50 Hellman. Oh, base ED.
No.
Oh, awesome.
Oh, yeah, no. No. No.
Co-op DTLS?
I
No,
can't see this.
that was the chair slides.
Right.
It must be base ED.
Well, but it's probably one of these.
No, that's slides from 90.
Oh.
Who's presenting?
Ludwig Sites. It's remote. Well, that's chair glitch. Back in a minute. We have 1, 2, 3, 4, 5, 6, 7, 8. So we should have it.
Meanwhile, can you hear me?
Yes.
Am I on? Really good.
Yes, you are. Hold on. We're trying to get your slides up.
Yeah, let me check the name I gave them when I send them to you, so you can search better. They're called ACE-AUTH-set.pdf. At least the file I send you, unless you changed its name.
It wasn't
Yeah,
on
all
the
right,
reflector.
It should be. Go back to your browser. And it's that one.
This one?
That one.
Yes, that looks good.
And it says failed. That's the problem.
Yep. Oh,
Oh,
because I turned it.
she turned her internet off so that
I
wouldn't
wouldn't
get
the little-
interrupted,
Yes.
which kind of makes it hard to download the slides. Yeah.
What about that internet thing?
Well, Jim and Carson gave us some head start, so
There we go.
Okay. So you're connected.
There we go.
Okay. All right. Slides are coming up. And we're ready. Go ahead, Ludwig.
So, good afternoon, I guess. It's early morning here in Sweden, as you can perhaps see in the background. I'm Ludwig Seitz. I'm presenting the authorization draft for ACE. Next slide, please. So last time we met in Berlin, we were at version 02. We got 2 very good reviews. So now we're at version 04. We did 1 iteration for each review as they came. Major changes, I would say 4 things, and then a number of small editorial changes, which I'm not going to talk about. The major changes is, first of all, I removed all the references to the OAuth proof of possession drafts, and I will go into that in detail. We clarified requirements on profiles, and I will give you a refresher on what the profiles are and what we require of them. We simplified the token requests method from a client to an authorization server, and we updated the security considerations quite considerably. Next slide, please. So, the OAuth proof of possession drafts. So I was told by the OAuth chairs, or rather by Hannes, one of the OAuth chairs, that the status of these drafts is not quite clear in the OAuth working group. And therefore, I decided it was not a good idea to have normative references to these drafts in our draft if we want to move forward. So I removed all the references and copied or rewrote relevant texts myself. So basically that gives us a situation where we have a specific ACE proof of possession specification in the framework draft here. And basically that's just saying that the profiles will need to specify the proof of possession protocols. Since in the division we did, it makes more sense to have that done per profile. And if you look at how it works out in OAuth, that seems to be a good approach. I mean, they have one for signing HTTP messages with the proof of possession key, and that's dependent on the transport protocol, in that case HTTP or HTTPS, I think. So I guess that's the right way of doing it. And since we are specifying different profiles for different transport protocols, that's where we also specify how you do the proof of possession. Anyway, you'll see examples in the 2 profiles we have at the moment, the OSCOAP and the GTLS profiles. And I also copied relevant security considerations with acknowledgements. I'm going to talk about that in more detail. And I would really ask for feedback on how good we managed to incorporate that, especially from people familiar with OAuth, and even better if they worked on the OAuth proof of possession part. Because we changed a few things, not monumental things, but still, and it would be really nice to have some feedback. Next slide, please. So, profiles, a quick refresher. Those of you who followed ACE through the different meetings might be familiar with that. I think it was presented in Berlin in summer. So we decided in the last iteration from 0.1 to 0.2, we decided to split the document into 2 parts. And this document would be a framework that only talks about the different endpoints. So how do you request a token? How do you request an introspection? How do you submit a token to a resource server? And then there would be profiles that specify bindings to transport protocols and communication protocols, and bindings to communication security that specify how you authenticate in these protocols and how you perform proof of possession. That also specify the content formats you will be using. And currently, they are also specifying discovery. So if you have a client that tries to connect to a resource server and you get rejected because you are not authorized, then the resource server should give you some information on how to find the authorization server. The first point, actually, the discovery, I'm not 100% sure if it belongs in profiles or if it rather should be in the framework. But currently we have it in the profile, and we have a very good write-up from Olaf Bergman in the DTLS profile, and we haven't gotten a very good write-up yet in the OSCOAP profile, but it will be in one of the next iterations. So currently we have two profiles. We have a profile using the object security for co-op over co-op, the OSCOAP profile. And we have another profile using DTLS over co-op over DTLS. And I am in contact with a group of people working on a profile for MQTT as a transport, as a communication protocol. And that's a very interesting one, because if that works, then my theory that we can make this split into frameworks and profiles gets a bit of support. Okay, so that's a refresher on the profiles. Next slide, please. So in version 02, the requirements, what profiles should specify, were scattered through the document. So basically at the appropriate moment in the document, it said, yeah, and if you're doing this and that request, then the profile has to specify the content format and how you authenticate, etc., etc. The result was that if you wanted to make a profile, you had to very, very carefully read everything to catch the sentence where it said, and a profile must do this and that. So we decided, in addition to that, we kept that, but we added a new section, Appendix C, that actually lists all these things. And there was a discussion between the authors, and we haven't actually done anything about it yet, whether that perhaps should be part of the normative text. I'm not 100% sure, since it's already in the normative text, it's only scattered, but if the working group thinks it's useful to put it in a separate section and make that section normative as well, I don't think it's a issue. I mean, we'll have double, or rather, we'll have requirements that are redundant, but I don't think it's a bad thing. Either way, I don't have a strong opinion. I will go with what the majority thinks is the best solution here. Next slide, please. Oh, and since I can't see the mic queue, I'm counting on the chairs to interrupt me if someone has a question and steps forward.
We will do that.
Thank you.
No need yet.
Yes. So, third point, third big change, the token request protocol. So when a client connects to the authorization server and requests an access token, this protocol, in version 02, we had a rather complicated protocol, or not rather complicated, but involving a lot of parameters with a lot of text, where the client could negotiate different parameters and the profile with the authorization server. And in the discussion between the authors, we decided that this was really over-engineered. It required a lot of text, and it would have required a lot of code. And basically, the resource server should be registered at the authorization server. So the authorization server should know the capabilities. And the client eventually also needs to register in order to be able to get an access token. And therefore, the authorization server would know what they both support and could itself calculate the best set of profile and parameters for them. So we removed the negotiation and let the authorization server determine the profile and the parameters and just inform the client what it has chosen in the reply to the token request. So have a look at that. It's section 6, if I'm not mistaken. Well, you'll find it. Go through the table of contents. It's the token endpoint, I think the chapter is called. Have a look at it and please give us feedback if you think that is a good idea or if we should bring back some negotiation. Next slide, please. So, security considerations, the last big change. Basically, what we did is there was a lot of very relevant text in the draft IETF of top key distribution. And this draft has expired, and I don't know what's going to happen with it. So I decided to salvage the relevant parts. And what I did was I copied, pasted, and adapted large parts of text, and then I put an acknowledgement in the acknowledgement section. I don't know if that is appropriate procedure. If not, please tell me and I'll fix that. But that's basically it. That works great. So that's basically it with the big changes between 02 and 04. And as I said, these were in reply to two detailed reviews, one by Renzo and one by Sigdem. So more reviews now, please. And next slide, please. We also think it's already possible to start implementing this. I think it's rather stable. I mean, I might be proven wrong by the next reviewer, but at the moment, I think it's stable enough, which means I have started implementing it. What I have ongoing at the moment is a Java library for the client, the authorization server, and the resource servers. And I'll make it available under BSD3 license. And we'll also later work on a C implementation for constrained devices for the client and the resource server. We are not going to make a C implementation for the authorization server. We assume that will not be constrained. And I will announce that on the ACE mailing list when I publish that. I'm also aware of a second implementation effort that just started. The Software Engineering Institute at Carnegie Mellon University is looking into ACE work. And they have a use case for tactical environments, and they have funding to work on this. And if I read the project plan correctly, they have an implementation target for third part of 2017. So we can expect to see some more code from there in third quarter of 2017. Also, they will start by analyzing our approach. They will start with a security analysis, and there might be interesting results from that one too, that they promised me to share on the ACE mailing list. So I think it's time, well, we think it's perhaps saying a bit much. I haven't talked to my co-authors about that, but I think it's time for implementations, and we might even consider if it's possible to do an interop at IETF98. I will check with the chairs when they are available again. And well, next slide. Basically, that's almost it. Yeah, that's it. Thank you very much. And please, questions.
There's a question.
Yes, Tony Nadlin, I have a question. Since you've sort of taken OAuth and changed it quite a bit, have you looked at all the vulnerabilities that we've discovered in OAuth and fixed those in your version?
Well, I left that in the trusty hands of Hannes, who has been telling us
that answers that one.
Proof of possession tokens, most of these problems go away. And other of the OAuth problems, if I understood it correctly, were related to the HTTP redirects part, where you get redirected from the resource server to the authorization server and then back to the resource server. And that isn't the case either in the ACE version of OAuth. So I haven't checked it actually, but it's certainly something we need to do. And I'm counting on Hannes and on the other OAuth specialists, Eric and Samuel, to do that, because I'm not that familiar with OAuth, or less familiar than they are, and I feel they will be do much better job of that.
Carsten Bauer, speaking of all the problems caused by redirect, we are going to have a segment tomorrow in the core meeting where we consider adding redirect to core. Maybe that's not necessary. We will find out tomorrow, just as a heads up.
Okay, thank you, Ludwig. We are now 15 minutes ahead of schedule, and we are about to get 45 minutes ahead of schedule instantly because the security for low latency group communication draft is next. I'm not sure we have any of the authors, and we don't have slides.
No, we have slides.
We do? We don't have slides for that one. Oh. Who is presenting? Okay,
Did
well.
you send the email?
Okay. Right, if no one's
Yeah,
presenting, who sent the slides? Okay. Okay. Well, we have time to do a little checking, so. Yeah, I don't even see it in the
It's not
in the
on-
archive yet.
No.
So, okay, well, we're skipping that one. We can always come back to it if something crops up. And so the next one is John Matson, the ephemeral Diffie-Hellman over COSI.
Unless there's a lot of questions, hopefully don't need 20 minutes, but now we have all the time in the world. So.
Yes, we do.
Yeah. So this is an update to EDHOC. Version 04 was submitted. And the main update of this is that we have changed the protocol from the NIST standardized Diffie-Hellman protocol to the Sigma protocol, Krabchuk's Sigma protocol. This is to align with the state of the art in Diffie-Hellman protocols. This has slightly better security properties when it comes to forward secrecy, for example. And IETF version 2 and TLS they're both based on Sigma. Sigma, by the way, stands for Sign and MAC. But these are mostly theoretical things. The main practical change is that this changes the protocol from 2 messages to 3 messages. But this does not mean that you have to do any more round trips. You can send application data protected with message 3, very similar to TLS 1.3. And the rest stays the same. It's still implemented using CBOR and COSI. It's still a Diffie-Hellman key exchange protocol with ephemeral keys. This is a Diffie-Hellman key exchange protocol implemented in COSI that you can use to exchange a traffic key to use to protect messages. For example, other COSI messages or OSCOAP messages. Next slide. So this is I'm very quickly going to go, I'm not going to go into very much into the details, just explain the high level how the protocol works. So you have 2 parties, you and we. They exchanged ephemeral keys and identities, and then they authenticate and they derive a traffic key called base key. Very simple. Can take next. So EDU, this is the ephemeral keys for party U and V sent the message 1 and 2. Next. Here are the identities. Next. And then sign and MAC, this is the authentication part. So party V authenticates in message 2 and party U authenticates in message 3. And this also includes a MAC of all the previous important parameters. Next. And then you derive the base key, which is used for traffic protection. And this party U has the base key when he sends message 3, and party U has the base key when he receives message 3. And this is the theoretical basic Sigma protocol as stated in Kravchuk's paper. Can take next. And then it comes to EDHOC. So EDHOC is built, the symmetric part is built on this basic Sigma protocol without encryption. The asymmetric EDHOC is built on the Sigma I protocol, which includes encryption. And then, as stated in Kravchuk's paper, to make a real protocol out of this theoretical Diffie-Hellman exchange, you need to add nonces. You need to add how the key derivation is done. And then you also need algorithm negotiation. So this has been added, and then it's realized using CBOR and COSI, which make it very easy to implement a protocol like this. And we allow 3 different authentication options: pre-shared keys, certificates, or raw public keys. Next. So here you see the encryption part. You still have the sign and MAC as in the basic Sigma protocol, but now you encrypt that together with the identities, which also protect the identity. They are not shown to a third party. Next. These are the nonces called N. Next. Here are the different symmetrical keys used only inside the protocol for different. Next. And here is the algorithm negotiation for what you are going to use the traffic key for. So in message 1, party U sends a list of algorithms, and in message 2, party V answers with one of the algorithms. Next. And here in prot here is, that includes the important parameters of the previous messages to make sure that you cannot do any bidding down attacks. All of these very standard ways of doing things. Next. So how does this look in practice? Here is the EDHOC message flows. And all of the EDHOC messages are CBOR. They're encoded in CBOR. Message 1 is that only includes that's a CBOR message. Message 2 and message 3, they are COSI messages. And as seen here, together with EDHOC message 3, the client or party U can start sending protected data. So you need one round trip to set up the traffic keys, and then you can start sending protected data. Next. And one example how you can implement this is that you can make use of COAP. where the co-op client is party you and the co-op server is party we. And here you can see, and you can here's in this example, OSCOAP is the traffic protocol that you use to protect the traffic in message here 3 and 4. So for example, you can do a post to a URI-path EDHOC or something else, and then you would include EDHOC message 1 in payload. You get an answer with EDHOC message 2 in a payload, and then you can send an OSCOAP request with EDHOC included in the OSCOAP option. And this is how EDHOC is used in the OSCOAP profile of ACE, which you will see a presentation of soon. But this would basically be how it would work with, if you could also use this to send a plain, ordinary cozy encrypted in message tree here. Next, this tries to illustrate some related work. So EDHOC is building heavily on cozy, and together with OSCOAP and ACE, it's used in the OSCOAP profile. Next. So next steps, we are aware of 2 implementations on the way, one from 6 and one from Jim. Very great that Jim is also implementing, hoping to do some testing between these future. I think as long as you have a compatible cozy implementation, it should be fairly easy to implement, I hope. We have got some good comments from Jim and from Ilari. We're working to implement these. This will be some optimization, some minor changes to the protocols. And after that, I think we will ask for CFRG review. Yeah. Any questions? Comments?
Mike Jones from Microsoft. I know that I don't have the expertise to review a variant Diffie-Hellman key exchange protocol, nor do I suspect that most people in the room do. So I guess I'd like more background on why this is being done here, why we need a different Diffie-Hellman, and why this isn't coming out of the CFRG if we do, rather than ACE.
We are planning to send it to CFRG. We have talked to Kenny Patterson. Yeah, we would be positive to any collaboration with CFRG.
Jim Schott, this is not a new Diffie-Hellman key exchange. This is a protocol that uses Diffie-Hellman to establish keys. Those aren't the same thing. Okay.
Fair enough. Why are we doing this work here?
As opposed to where in TLS? Yeah.
Francesca Palombini, and this is useful for the presentation that is coming next. That is the OSCOAP profile and is using EDHOC. So I think that without this presentation here, you would not really follow the OSCOAP profile.
Shemshad, one minor updates may be a bit optimistic, but that's okay.
Yeah.
If you go back to where you were doing the symmetric one,
I don't think that's
in one case, well, I mean, for symmetric, you're using sigma I. For asymmetric, for symmetric, you're based on sigma. For asymmetric, you're based on sigma I.
Yeah, correct.
Given that you're sending identifiers in both cases, it's not at all clear to me that you shouldn't be using sigma I in both cases. If you're sending IDU and IDV, those are potentially long-term identifiers and need to be protected.
Yeah, I kind of agree. I think we are looking at that. It might actually make things simpler to use encryption in both cases. Yeah.
So Ludwig Seitz from Jabber, it's basically Diffie-Hellman for constrained environments. That's why it belongs here, in my humble opinion.
All right, other comments, questions, discussion? Francesca, you're up.
Oh, this one. Yes, for once. I was writing.
Hello.
Yes.
Hi, I will be presenting the OSCOAP profile for ACE. Next. So this is a slide to remind you of what OSCOAP is. Some of you have seen this 4 times during this IETF meeting. So I'm going to go really quick on this one. So OSCOAP defines a method for in-layer security of COAP message exchanges using COSI format. Next. This is the related work to this. So you can see the OSCOAP profile highlighted in top left. And this is dependent on the ACE framework ad hoc and OSCOAP drafts. Next. Also, in parallel of this work, there is the DTLS profile that has been developed and will be presented by Karsten, I believe. Next. This is a slide to remind you about the basic protocol flow for the ACE framework. So we have a client sending a token request to the authorization server, the access token plus the RS information is sent back, and then the client interacts with the resource server, send this the request plus the token, and receives back the protected resource. And as Ludwig mentioned before, we define most precisely what the token contains and how is the communication with the resource server protected. Next. Status of this draft. So there exists a GitHub for this draft. You can see here. It's been updated according to OSCOAP and had ad hoc updates. So OSCOAP was discussed in core. If you missed that, you can see the recordings. And ad hoc was just presented. So one update, as I think John mentioned, is that ad hoc is now a 3-pass protocol, but ad hoc plus OSCOAP is still 2 round trips because we combine the 3rd message of ad hoc with the first OSCOAP message. Next. So this is the interesting slide. If you have to follow something, follow this one. So this is the profile description. The client sends the access token request and receives the access token plus the RS information, including the profile COAP OSCOAP. The access token contains, depending on the use case, three possible things. So if OSCOAP only is used, 5 parameters are included in the access token, which are the symmetric key, a context identifier, AEAD algorithm, client identifier, and server identifier. If OSCOAP plus ad hoc are used, then symmetric key and key identifier must be sent in the access token if symmetric key is used, or just the asymmetric key if asymmetric keys are used. And all the other parameters that you can see in OSCOAP only are derived from the ad hoc message exchange. Then the client sends post request to the resource server, posting the access token to the resource server to the auth info. Then it receives a response with including So it message in the first request, if EDHOC is used, also EDHOC message 1 is sent, and message 2 is sent in the response to the client. And then OSCOAP request is sent to the resource server, including message 3 of EDHOC, if EDHOC is used, and then the OSCOAP response. Next. So this is the detail of what I just said about the communication between client and resource server.
Sorry, I got you.
Yes, so there are some detail about what the URI path is, what I said, auth info, what the content type is, and what the payload includes. So for the case of EDHOC plus OSCOAP, it's EDHOC message 1 plus the access token. The second message, the response includes the EDHOC message 2 in the payload, and then the OSCOAP request includes the EDHOC message 3 in the unprotected header of the COSI encrypt 0, and then OSCOAP, the response includes the object security option. So it's OSCOAP. It's protected with the OSCOAP. Yes, Karsten?
Carsten Bormann, how does the resource server know that this is an ad hoc exchange?
Because it includes the EDHOC message.
Yes, is that completely self-describing? So usually we use something like a media type to identify something like that, and you use the generic media type application CBOR here, and maybe it's worth getting a number for that.
Thank you. Point taken.
Tony Nadlin, what are you doing as far as the refresh token is concerned?
In that case, I think you would have to rerun the.
You'd have to rerun.
Well, you have to get the.
Will you include those flows in? Are you going to go over those flows?
Sorry, can you say that again?
Are you going to go over the refresh token flows? Yes.
No. But if you get a new token, then you'll probably have to rerun. So if you're using EDHOC, then you have to rerun EDHOC to derive the information again. Maybe you can go back one slide, I think.
This one?
Yes. So when you get the token back from the AS, then you have to run EDHOC to derive all the information that is used to protect.
So you're not getting a refresh token, is that correct?
I think so. I'm not sure of what the resource refresh token is. So.
Okay.
All right, and Ludwig has comments, so let's see how this works. Ludwig, go ahead.
Hello. I hope you can hear me. Yes?
Yes.
So
Yes.
basically, about the refresh tokens, Hannes was scheduled to write something about those in the framework, not refresh, sorry. He was scheduled to write something about the grants. And I think this is a valid issue for something we should also address in the framework, because right now the framework doesn't talk about refresh tokens at all. And obviously, this is a deficiency of the framework and not of the profiles. So I'll keep that in mind, and I'm going to create an issue in the issue tracker for the framework to address this, and then we need to formulate specific requirements on the profiles to do that. So that's actually my bad, not Francesca's.
Yeah, we haven't considered this for the profile. Next.
You want me to? One more? This one.
One more. So for OSCOAP only, the EDHOC messages disappear from the communication, of course. Next. So this is a slide of comparison between using OSCOAP only or EDHOC plus OSCOAP. So if you use EDHOC plus OSCOAP, you're gonna, of course, have a smaller access token in RS info because you derive the rest of the information. and you're gonna get perfect forward secrecy because you're using EDHOC. If you use OSCOAP only, then you're gonna have smaller messages because there are no EDHOC messages being sent back and forth, and it can fit into one round trip, and we will look into this. And you have an example here. Basically, the access token will be sent in the first OSCOAP request. Next. So next steps, get feedback, of course, if you have comments. And there is a 6 implementation on the way. And also we have a few examples that will be using this profile as, for example, authorization and key distribution for PubSub and multicast. That's it.
Other questions, comments, discussion?
Just a moment. Should I be implementing this now, or is it something that's still very much in flux?
We have a few modifications to do according to Jim's comments, mostly on EDHOC. So maybe wait a little bit, but we plan on doing this very quickly. So before next meeting, of course.
So would it maybe a good thing to follow the same procedure that we discussed in core, that we at some point we identify a version as an implementation draft?
Yes, that will be good. And we will try to keep you updated on the mailing list about when we think this draft is ready for implementation. And of course, reviews are always welcome.
And Ludwig has created a new issue in the issue tracker. Thank you, Francesca. Karsten, you're up again, DTLS profile. Yep.
Okay, so we're going to do a little bit of PowerPoint karaoke here. So normally in a list of authors, the professor's at the end and knows who the people are who know what's in the draft. So let's see how I managed this. So next slide. The basic idea is that the framework gives us a lot of tools, and we want to use those tools with DTLS. We start with sending a token request to an authorization server, getting an access token, and then the DTLS connection can be opened. And possibly before that happens, the client does some discovery. Now, one way of discovery that we have been discussing, and that's certainly optional, is that a resource server that is unhappy with the level of authorization the client has can send back an authorization server hint, which tells the client, hey, talk to this authorization server so you can prove your authorization. The access token really is the thing that goes into the DTLS step next. Once we have this access token, we can do the DTLS channel setup. Now we have two variants here. In the raw public key mode, we don't really have a place in DTLS to make use of the access token. So we have a separate exchange, an unprotected exchange, that is happening before the DTLS connection, where the client just tells the server the access token. And in pairwise symmetric key mode, we actually use the key in the channel setup. So DTLS is essentially our proof of possession protocol here. And then we can make authorized requests and get it protected resources, and so on. So the client essentially authenticates to the resource server by being able to set up the DTLS connection. That's the idea here. Next slide. So once the DTLS channel is open, we might want to update the access token because we have received some new authorization, qualified for some new authorization. And to do this, we can do another token request and essentially use the same mechanism we have been using in the raw public key case for the client to send the access token to the resource server. So after updating the authorization info, we can now continue with authorized requests based on the new access token. Now, an alternative is actually to throw away the DTLS session and just do another DTLS session. Which of the two makes sense in a particular case depends on your implementation. Of course, you always must be able to throw away your DTLS session and do a new one. So this is maybe trivial, but that's an alternative implementation strategy. Next slide. So in RPK mode, the client uses the OAuth thing to talk to the token resource at the authorization server and provides information about essentially who it is, for instance, in the form of a raw public key or in the form of a known unique identifier for the public key. And the authorization server sends back the access token. This is shown in base 64 encoding here because that's the diagnostic notation for CBOR, but of course it's not base 64 encoded, it's included in binary. And the authorization server can give some additional information here. For instance, if we are using RPK, then the authorization server gives the client the public key that it uses to authenticate the resource server. Okay, and then C uploads the access token to the resource server before it actually does the handshake, as I showed. Right? In pairwise symmetric key mode, the client has a somewhat simpler situation because the assumption is we have a DTLS connection to the authorization server, so it essentially just says, give me a token, and next slide, it gets one which essentially looks the same way, except that we have a symmetric key now that the client uses to build the connection, the DTLS connection to the resource server. Now, of course, the fun part about the protocol is that the resource server can generate the key from the access token that is provided to it. Next slide. So in pairwise symmetric key mode, we do the channel setup by using the key as the shared secret. The client gets it directly from the authorization server. The resource server can extract the shared secret from the access token. And this is placed into the access token by the authorization server using some pairwise symmetric key between the resource server and the authorization server. Or it can be built using a hash function, hash-based key derivation function from information that is available here. When updating authorization information, as I said, we either update the access token in /OSCE info, or we renegotiate the EDHOC session with a new access token. Next slide. So what needs to be done? There is a question of division of work between the profile and the framework document. So who actually gets to describe the authorization server discovery? What we described there, you make an access to the server and you get back an unauthorized, but not just the unauthorized, but also a hint where the authorization server is. That's not limited to the DTLS profile. So why are we describing it here? The error handling could move to the framework. And there is some text in the draft right now that admonishes the server not to reveal too much information based on 403 and 405 responses. And finally, we should be making use of the recent work about time-based and timeless security methods. So we look at how to use timestamps as a nonce. Okay. Questions?
Ludwig comes. Ludwig speaks.
Hello. I have a more general question. Since we've now seen two profiles, I have a more general question to the working group that I would like to discuss. And this is, both profiles and the framework have a number of assumptions on that the client and the resource server have some existing relation to the authorization server. So the authorization server is assumed to have registered parameters about at least the resource server and probably also the client in order to make the decision whether to give it an access token or not. And I'm vaguely aware that there is in OAuth there is some registration protocol. I think it's a dynamic client registration protocol, and I don't know if there is a similar resource server registration protocol. And I wonder whether we here in ACE should make a constrained environments variant of these registration protocols. I would like to hear opinions from the room about that.
This is Justin Richer. I do think that probably makes sense for ACE to investigate, along with sort of a deeper investigation of the discovery process. I noticed in the middle of that presentation there was a, I'm going to classify it as a hand wave just because it was not the main point of the presentation, of oh, this is where your authorization server is, just go talk to it now, and stuff like that. Resource-directed discovery is a very difficult problem to get right. And it's something that the OAuth working group discussed earlier this week as well. And so it's definitely, what I'm saying is that I agree with Ludwig that the registration is definitely part of the problem. I think that ACE should consider it, especially in a dynamic environment, but also discovery and sort of, configuration requirements really need to be considered alongside of that as well. They're kind of two halves of the same problem set.
So can you go to slide 2 again?
So Tony Nadlin, what comes along with the dynamic registration is the issues about management of it. And you're going to have to get into that, which is not a nice situation to actually be in. I'm not sure how many people have actually implemented the dynamic registration or not. I know that a lot of the large companies have not.
Yeah, so what Justin said, this information here, this authorization server information, of course, is only useful to the client if the client has a pre-established relationship to this authorization server. There is what kind of information should be in here that would enable a client to set up a new relationship to the authorization server. That's a bit difficult to say because there's a lot of business logic specific stuff that would go in there. And that's kind of an artifact of doing this three-legged approach because the fourth leg is missing that would supply this information. So that is always going to be a little bit a weird part of this.
Okay, I guess we're done here. So now, Renzo, it's your turn to step up to the remote mic. How do I request? You can click the hand up button and I will unmute you when that happens. Here he goes. And speak to us, please. Yes, there you are. Hi.
Good evening, Seoul. Okay. First, thank you, Lorenzo, for from the Miteco team that helped me to set up all this. It's wonderful to be here virtually. So initially I had 10 minutes. I think maybe we have a little bit more time, but let's get started.
I think maybe.
Okay. I'm Renzo Navas, together with Göran Selander and Ludwig Seitz. We are the authors of the Lightweight Authenticated Time Synchronization Protocol. I like to call it LATE. This is version 0, so I will explain the basics and other things. Next slide, please. So first, some background and motivation for the work. I will talk about freshness of information exchanges that can be basically assured by two types of mechanisms. One is the use of timestamps, and the other is the use of nonce-based exchanges. For the time-based solution, they typically have one less message than a nonce counterpart protocol, so that simplifies the overall protocol, and that is good. But of course, one of the drawbacks is that we need yet another protocol, and it's a secure time synchronization protocol. In the ACE working group, the ACE framework needs time synchronization for OAuth proof of possession token validation and expiration, except if we assume an introspection setting. Next slide, please. Shall I speak more slow because I have 10 minutes, so but okay.
You're fine.
Okay.
Whatever you want to do.
Okay. More about secure time source. In most security services, they somehow assume time is there, but surprisingly, it doesn't yet exist a comprehensive solution. NTP-v4 provides an authenticated mode, but it's kind of sort of a egg chicken problem. It has a circular interdependence. It's explained there on the security section. The cryptographic values have to be enforced, which depend on a reliable source of time, and at the same time, we need to synchronize the time securely, so we incur on the circular interdependence. This can be solved. This problem has been stopped on the network time working group. and they are defining a draft called network time security, which basically adds some message on top of any time protocol. But these solutions, the future solutions for secure time synchronization, are not resource constraint friendly. For instance, the lightweight solution the network time security provides needs 6 messages on top of the NTP, and they don't specify how to encode the message, and for what I've seen, they are not resource friendly at all. Next slide, please. So now I start with the presentation of the late protocol. First, I will talk about the goals. The functional goal is to enable a constrained device to obtain a local time representation from a trusted source. So we assume we have some pre-shared cryptographic information. And also that value will have an associated uncertainty, basically the round trip time. So we have 2 explicit security goals. One is authentication, and the second one is freshness. Of course, freshness will be achieved by nonce methods. Another design goals are, we try to be lightweight. There's the fewest message possible, basically 2, I think is the less we can achieve. And we use CBOR and COSE, which makes the protocol to be easily transport over any datagram transport. And we, in the main draft, we map it on top of COAP application protocol explicitly. And also we designed the protocol to be easily used on top of the ACE framework. We will see later that we can embed the protocol piggyback on a full ACE message flow. One of the non-goals is worth mentioning is that we don't try to achieve accurate time precision. It's rough. I think for most IoT applications, it's good enough. Next slide, please. So this is the base protocol. This is from mostly to analyze from a cryptographic and functional point of view. We have 2 entities. I put the client on the right to make it easily later to map to the ACE framework. So basically 2 messages. The time client initiates the protocol. This information contains a random nonce and a key ID. Actually, we need some kind of ID for the time server to identify who is initiating the protocol and to encrypt accordingly. For privacy issues, I think key ID is a good compromise between disclosing the identity and identifying the other party. So this message is unencrypted. It has no security properties. And the time server then will reply with the same nonce, its time representation, and authentication tag of both information. Then the time client with this information can calculate the time using first will authenticate, match the nonce, which will assure freshness, and then calculate the time as the time server time, plus half the round trip time. Next slide, please. So this is more how we encrypt or how we encode this information. We will be using CBOR maps. On the left, we have the first message that we call a tick information CBOR map. Basically, we have a nonce and a KID. And optionally, we added an algorithm to specify the algorithm the server has to use. And also the server, this is related with how to discover the server in the case we have a proxy that will help us to finish the protocol. On the right, we have the response that will come from the server, will be encoded using a CBOR map that is called TOC response. And basically, they have the time and the nonce. Next slide, please. And this TOC response has to be authenticated, so we will use a COSI MAC message to achieve authentication of this information. Next slide, please. Now this COSI message, we are using COAP to execute the protocol. So this is a full execution of the protocol that can work in real life. The client will send a post to the time server, to the time resource. We make use of the content format of COAP to specify that this is a late protocol message and it's a tick message particularly. And in the payload, we will have the CBOR message. In this example, I use the diagnostic notation. So next slide, please. So the server will reply with a COSI MAC TOC response. As you see, we use content type again to specify this is a TOC message. And then this is a COSI message in which in the payload we have the TOC response. Next slide, please. How am I on time? I think it's okay. So now do the most. Now we will see how to map this protocol on top of ACE framework. First, we will do some actors mapping. The authorization server from ACE will be acting as the time server. The resource server that I assume to be constrained will be the time client. And the OAuth client will simply relay message. One nice property of the protocol is that the client doesn't need to modify the message. It can send it as they are. And then we recognize possible scenarios for the execution of the protocol. But now I will present, I believe, the most useful and maybe the most complex. That is when the client initiates. Next slide, please. When the client initiates, makes a resource request to a resource server, and in this case, the resource server doesn't have a security association, so it will reply with a need for the client to initiate a token request, and we will piggyback also in message number 2. We can see we will reply with unauthorize. We will say some ICE information as Karsten explained before. This needs to be defined how we do this, and we also piggyback the tick CBOR message. Then the client will go ahead with the ACE framework, ACE solution token request, message number 3. It will also include the tick message. Server will provide, if everything is okay, the token response, and we can include the authenticated TOC, sorry. Then the client will post the outs.inf resource of the client, the token, plus the authenticated TOC. And if everything goes well, we achieve token provisioning plus the time synchronization. That can be used to validate the same token that is contained. Next slide, please. So this is some details of message number 2. Basically, we need to include a way to, or maybe not if the client already knows, but we can include the server URI, and the rest of the message can be simply a CBOR tick, sorry. Next slide, please. And basically in the 5th message, when the client will post the authorization token, in the content format, we can specify we are also transporting a late message. On top of the COSI WIP token, we can also include the TOC, the COSI MAC TOC response. So next slide, please. So basically that was it. But now I will speak about next steps. To cryptographically analyze in depth the base protocol, we did some, we studied some attacks paper and provided some mitigation. But as the protocol is very simple, I assume it can be easily ported to some kind of crypto model to be automatically analyzed for possible attacks. And also, I think it will be very good to involve a crypto person. If somebody's in the room, please take note. I will send a message maybe to Crypto Forum Research Group. As you see, it's a very simple protocol, but we have to make sure it's done right. Also, to refine the ACE scenarios, as the ACE also will evolve, we have to see how to properly map on top of it. And please read the draft and send feedback. Next slide, please. And this is to finish the presentation and hopefully start some kind of discussion. The question is, do we need a secure lightweight time synchronization mechanism on ACE? First, from my point of view, the answer is maybe. If the answer is no, then we will need to use nonces everywhere. And every protocol we have to define a way how to include nonce on top of it. It's not easy task. I'm also pro non, let's say. It's interesting solution when we cannot achieve time synchronization. But if we can achieve time synchronization, I think it's worth it to run time synchronization protocol and then use all kind of protocol that assume secure time is there. So if the answer is yes, another question to ask, how we will achieve time synchronization? This is one, we will wait maybe for NTP to come up with a secure solution. If they come up, they will come up with something, but I have my doubts that it will be easily used in ACE. So that's why we present this protocol. Next slide, and that's it. Thank you, and I'm open to hear comments. Or read the draft and send to the mail.
Yep, we have someone at the mic. Go ahead.
Hi, this is Zhang. Just page 5, you mentioned the trusted entity. So this trusted entity is a precondition or it's guaranteed by this solution?
No, it's an hypothesis. We assume we already have some cryptographic material with some trusted entity. If we don't assume that, we cannot achieve what we say. In the draft is all the security hypotheses are explicitly exposed.
Carsten Baumann, yeah, indeed, the assumption here, as with all the other ACE work, is that the resource server has an established security association with the authorization server, so we know that there is a key that can be used here. And I think this is a very nice solution for the problem. The issue of nonce uniqueness, of course, is always a problem in a embedded system, in a constrained system. So maybe the discussion should be a little bit expanded about that in the draft. But apart from that, I think this could work very well.
Thank you, Carsten. Yes, actually, how to create the nonce is very important, and in the security sections we provide with requests, and of course we need to study how a constrained device can create a random nonce. Is not an easy task. There are several possible solutions. Even we can have a counter, a random counter that is provided to the device, and then this counter is encrypted with a key, and so it's sort of a random nonce without having a true random number generator. But it's a hard problem, yes, how to generate quality nonces.
Matthias Kovac, Siemens. So it's an interesting question or statement that there is no time synchronization protocol for constrained nodes. So there's no standardized one. So I've been wondering actually for a long time, there was a lot of work in the high time of wireless sensor networks where there are protocols to have a microsecond synchronization between lots of nodes across a high number of hops and so on. And none of this work was ever standardized. So usually you need that if you want to have proper sensor readings and so on. So for a lot of applications, you use it. And yeah, now here in security, of course, you also kind of want to have that. So I don't know if it's more a larger test that should be investigated to have a standardized alternative to NTP, something that really fits these low power networks with multi-hop communication and so on. Especially because there's a huge body of work and research results actually on that.
Johnny?
Yeah, Tony Nadlin, are you, I guess what I'm trying to understand is you have to have a prior relationship between your authorization server and resource servers. So if you wind up having multiple resource servers out there, that means you have to have a relationship, predefined relationship with each one of these?
Yes, normally yes, but in the constraint setting, you normally have only one trusted entity that does everything for you. But yes, if you have multiple servers, you will need multiple cryptographic information with each of them.
Carsten Mormann again. I think the issue how to get application level time synchronization is a bit different from the issue how do we get time synchronization that is good enough for validating certificate lifetimes and things like that. So the second one is a little bit like the Back to the Future situation where you are picking up a newspaper out of the garbage bin to find out what year it is. That's very different in requirements from I actually want to synchronize my clock. Once you have set up security and good symmetric security, it's much easier to do the precise time synchronization. So I think that this might be something that bootstraps the other thing.
Good point. Yeah. Actually, the protocol can be transported on any, maybe even on top of layer 2, but without co-op. But yes, it's a good point. But I think there is a lot of work to do.
Karsten goes back to the mic.
You could even transport it on top of layer 2 with co-op. I have a draft for that.
Okay, so even better.
Okay, no one else at the mic. Gracias, Renzo.
De nada. Good evening. Okay. I have to leave.
So,
have a good
yeah,
night.
I'll press the button again, and you should go away. There we go. Feel free to come back and raise your hand again. So we had a request for a last-minute addition, and given that we have a minute or two available, we should.
Yeah. So I don't know if Peter is here.
Yep.
Okay. So given that Karsten prefaced the meeting with co-op EST, Peter. And then I'll have a comment. It's up to the group whether they want to leave early or not.
Okay.
Well, we're not ready to leave yet, so go ahead.
Yeah, don't go. Yeah.
Okay. I'll try to be entertaining. It's difficult. Thank you very much for the opportunity.
Not a problem.
My name is Peter van der Stok.
Here,
I am Peter van der Stok. I'm working with lighting people and installation in buildings, and those people are putting all these devices onto a network, and actually they make this an IPv6 network, and this could get connected to the whole world. We think for small devices it's not. The content formats for the co-op registry, because there are lots of those convert MIME types which are used in EST, which we actually want to use there. And explains use of lock. I said we use binary instead of proposal. Co-op response code 2.0 is specified. It doesn't exist, but it gives the possibility that you have delayed answers. So you ask for a registrar, in this case, for please, can you tell me if this device is okay? And what do you know about it? And this goes then to some service in the cloud, which may be of a manufacturer. And it may actually be that the service in the cloud hesitates and asks somebody else, which is actually a person, look here, do you know anything about that? So we have short answers, usually, and we have long answers, but that's not foreseen in co-op, so that has to be added here. So, how long ago now?
You have plenty of time.
You're right.
You're fine.
Okay, so we have a draft Britican co-op bootstrap, which has discusses the same parts, but has a different view of looking at it. They describe how what the format of the header of co-op should be. Well, we do not, because we say, oh, everybody knows. And and there are other differences, but actually the contents is the same, so we should certainly merge those two drafts. Next slide. And so the questions I have to you is there interest in Brisky over in this group, so of what's going on here, that you can do this bootstrapping? Do you agree with it that we're going to work over EST, over co-op as within this working group? Or do you think, look here, why don't you invent something new? And you say, well, let's do that. Or do you agree with it? But that's other questions. So first, I think that's the first two questions. Are you interested? Do you think, please do this work here and get feedback for you for this all this security information? Well, we bring in more of this co-op and building knowledge. No, I see that you impressed everybody.
Brian Wise from Cisco. I think it's these two protocols, the Brusky and the EST, are both really valuable for working with an manufacturing certificate and IEEE 802.1a or IDEV-ID, we call it, which is a nice, the three go together with a nice zero-touch sort of provisioning method that gets you to a local certificate, then you can use it for whatever you want. And it's to the extent that we want to encourage devices to use client certificates, I think this is really a great approach. We should go ahead and do the co-op work for these protocols.
Thank you.
So, yeah.
I think this is a perfectly good working group.
Yeah, so I'll speak. I'm going to take my chair hat off. So Nancy Kim Widget from Cisco. So to echo Brian, the 6TISH group is also the design team is looking at it. So Brian called out a use case for manufacturing. We're looking at it from a utility standpoint. I know that that design team has done an evaluation, and we are working on aligning the Brusky. So it really is a question of, and I will echo Brian also, that Brusky is a nice framework to be able to do this. It'd be good if we could look at ways of doing that convergence once for the general set of constrained network use cases. This being one of the places, yes. Yeah.
Carsten Bormann. Of course, in the end, it's the job of the ADs to decide which working group should work on something. I can only give my educated guess here. And, well, if we define a new response code for co-op, we certainly will do that in core. That would be a separate document, maybe a very short one. But the rest is security relevant. And this working group has turned something into the security arm of the core group. So this is a very natural place to do this kind of work.
Jim Schott. I got to find out more about Ruski before I can say whether or not I'm interested in it. It's like I scanned the documents and I haven't managed to get far enough into them to know for sure. If we're doing enrollment protocols, EST is the correct way to do it at the moment. And so definitely, if we think enrollment protocols are important to get certificates, that is the way we want to do it, and we want to do it over co-op. So that is definitely something that is definitely the right way to do it.
So Jim, are you saying you're not saying this group, you're just saying in general?
In general.
Okay.
Right. In terms of full EST or subset, I think you'd probably define the full and find out what happens, because I don't think we know what we want. And in point of fact, I was presented a document this week that has some extensions for EST that might actually be of interest. So, I'm not too sure what that set is going to end up being. On the other hand, since almost all of this is basically talk to a different it's a different URL, and you get a different service, it probably doesn't really matter. And just in terms of what we require versus what we don't require. Where to do it? I go to these to the ACE working group meetings already, so I'd probably prefer it done here rather than something like 6TISH, which I don't go to at the moment because it conflicts with all my other meetings that I have to go to. So of the working groups that I show up in, this is probably the best fit that I can think of.
Brian Wise again. I guess I'd like to see the work continue. I don't mind if it's here or in 6TISH. This seems to be more related to authentication, so it seems like it'd be a better fit to me, but I'm certainly happy whatever the ADs decide.
And then AD cometh.
Kathleen Moriarty, AD. I think it's up to the working group first to decide if they'd like to adopt this. And then the only time I've interjected with this working group to help decide if work should go here or somewhere else was when we had a lot of disagreement. Right, so let's take the normal steps first before I have to. Well, hopefully, we won't come to the need for an AD to make a decision, but the group decides. Right, that's why we have working groups.
Okay, so do we have a general interest in picking this up? Hum, if you think this working group should take this on. It sounds like we have some interest. Hum, if you strongly object to that. All right, so I suggest that you post to the ACE mailing list about this and get some discussion started on the mailing list.
Thank you very much. Very grateful.
Do we have time for another elevator pitch?
Well, sorry?
Oh, there is.
Joran, go ahead.
There's a Pac-Man.
Can you
go ahead, Joran, you can speak.
Hello?
Yes.
Yes, and we can hear you.
I was just curious about the change of work in this working group. So we have a number of drafts which are not yet adopted, and I just want to make sure that there is space in the working group to discuss them as well. Do you want to have a call for adoption for the some of the other drafts being discussed in this meeting, or?
So just as a point of order, Joran, we did not adopt that document.
Right.
We just accepted that discussing it on the mailing list was interesting to people for now, and we'll see where that goes.
Discussing the topic.
Yes.
Okay, but then I have a proposal then that maybe we could go through, ask the working group about the drafts previously presented in this meeting, whether the group thinks that this is ready for adoption or sort of the maturity of those drafts.
Yeah, I am not comfortable as sit-in chair. I'm not comfortable going that way. I think we should take that to the mailing list and let the actual chairs drive the discussion.
Okay, fair enough. Thank you.
Yep. All right. Thank you, Karsten.
Do we have time for another elevator pitch?
Sure. We have slow elevators, so you can go ahead and pitch it.
Do you have slides? You did not. Voila, the other way.
Okay, so I already talked about this in SAG briefly a couple of meetings ago. One problem that we run into is that if you want to find out whether a device is still uncompromised, still runs the right firmware and so on, right now the protocols for that are pretty heavyweight. And in particular, they require exchanges between a requester and the device. And if you want to aggregate information like that in a management system and want to aggregate it repeatedly because you want to have up-to-date information about whether your device is still okay, that's all becoming a bit expensive. So there was this interesting idea of doing time-based unidirectional attestation. So this essentially means instead of having attestation as a request-response thing, the device can spontaneously generate information that can be used by other parties to verify that this device still works. Now, under the cover, that the device to actually generate that attestation probably needs to talk with some server. So there is still this request-response thing going on under the cover. But then the information that is generated as the result of that interchange, that actually has a life on its own. It's kind of secured by object security. So you can put it into management systems and have it for other systems that can verify what's going on. So the current version of this document is based on TPM 1.2. That may not be something we want to do in the long run, so there's probably some development desired, but the protocol is complete, it works, and it could be something that is a component for for securing large herds of embedded devices. So we have been running around and looking for a home for this work, and I just noticed, oh, this group here is becoming an interesting receptacle for work of this kind, CBOR-based and all that. So I just wanted to make the pitch here.
Austin, you want this? Damn, I thought I'd have something extra to take on. Okay. Unfortunately, it looks like Mike left. I was hoping that we could have a bit of the keys to the light bulb discussion, but it's not. There's not really a lot of point of having it without him. But he raised in his message this afternoon. He raised a significant issue that I think you guys need to think about. Given the recent attacks on the internet by IoT botnets, there's a further consideration that should be undertaken, whether the symmetric group key solution applied to tens of thousands of IoT devices is an active threat to the rest of the internet. So think about that and respond on the mailing list, given that unfortunately we can't have the discussion in the room without the person who posted it. Ludwig. Yep.
He got eaten.
He got eaten. Ludwig, if you had something you wanted to say, raise your hand again, please. And if not, then I think we are done. Does anyone else have anything they want to say? Did anyone not sign the blue sheets?
And who has the other blue sheet?
So sign the blue sheets before you leave if you haven't already, and thank you for coming.
Boy, I thought we would have